Hello guys, welcome back to my channel. In this video, we're going to talk about attribute selection measures and a mathematical expression for information gain, Gini index, and reduction in impurity. And further, we will talk about some data science terms like data pruning and overfitting. So, let's get started. Attribute selection methods. So, attribute selection methods introduction. We will start with the introduction first. Obviously, attribution selection measures are also known as attribute evaluation or feature selection measures, which are used in machine learning to access the relevance and importance of different features or attribute, obviously, in a data set. What are these measures? These measures are typically used to help the algorithms decide which feature is to be included or to exclude during the learning process or data analytic process. So here are the explanations for three common attribute selection measures. So let's get started. First is obviously information gain. So the concept of information gain is widely used in decision tree algorithms, particularly in ID3 and C4.5 algorithms. It measures the effectiveness of attribute in reducing the uncertainty about the class level in the dataset. So for calculation, for a given attribute A, information gain is calculated as the difference between entropy of the data set before and after the split on the attribute A. Mathematically, it is defined as follows. Obviously, it is given in this video. Information gain A is equal to entropy D minus summation of values A dv by d, that is obviously probability, multiplied by entropy of dv, where d is a data set, dv is a subset of d, where attribute a has value v and entropy d is the entropy of the data set. Next is obviously gain ratio. So the gain ratio is an improvement or over an information gain, which is designed to address the bias towards the attribute with a large number of values. It normalizes the information gain by taking into account the intrinsic information of an attribute. Calculation of gain ratio is as follows. The gain ratio of attribute E is calculated as gain ratio A is equal to information gain A divided by split information A, where split information A is a measure of amount of disorder in a dataset due to attribute A's multiple value. Okay. Second, we have Gini index. Concept of the Gini index is commonly used in card classification and regression tree algorithms. It measures the impurity or disorder of a dataset, indicating how often randomly chosen element would be incorrectly classified. So the concept of Gini index is commonly used in card classification and regression tree algorithm. It measures the impurity or disorder of a dataset, indicating how often a randomly chosen element would be incorrectly classified. Calculation for Gini index is as follows. Gini index A is equal to 1 minus summation of values of A in a bracket dv by d whole square, which is basically a probability for that particular attribute. A lower the Gini index indicates the better attributes as it reflects the better separation of a dataset into distinct classes. So yeah, now we'll talk about the mathematical expression for information gain, Gini index, and reduction in impurity. So for classification of the tree, first we will talk about the information gain. The definition of the information gain is basically it is a measure which is used for decision tree algorithm for selecting an attribute that results in most significant reduction in entropy. Entropy means randomness or impurity when a data set is split. So mathematical expression is obviously information gain entropy before split minus weighted average entropy after split. Information gain before split minus after split. Here it is obviously given. Second, we'll talk about Gini index. So, what is Gini index? We have already discussed, but again, we will define it in a more bookish language. So yes, Gini index is a measure of impurity used in decision tree algorithms for classification tasks. It quantifies the probability of misclassifying an instance randomly chosen from for a dataset. Gini index is equal to Gini index 1 minus summation of pi square. Okay, PI is a probability for that particular attribute. Okay. Say next is reduction in impurity. It is a generic term that refers to decrease in impurity or disorder achieved by splitting a data set based on a particular attribute. It can be expressed differently depending upon the impurity measure, which can be either information gain or Gini index. So mathematical expression for impurity in reduction will be impurity before split minus weighted average impurity after split. Specific expression for information gain, it will be reduction in impurity. For information gain before split minus information gain after split. For Gini index before split and Gini index after split. So yes, next we will talk about overfitting and tree pruning, basic concepts of data science. So yeah, overfitting is a common issue in machine learning where models learns not only the underlying patterns in the training data but also captures the noise and random fluctuations present in the data. As a result, overfitting models perform well on training set but poorly on new and unseen data. Essentially, the model becomes too complex and fit the training data too closely, losing its ability to generalize the new examples. In context of decision tree, overfitting can occur when tree is allowed to grow deep and capture detail specific to the training data, including outliers and noise. This results in highly branched tree and may not generalize well with the new data. It means too much information, which makes it very, very complicated. So yeah, next is obviously tree pruning. So tree pruning is a technique used to address the overfitting in decision tree by removing the branches that are basically subtrees of the decision tree, and do not and these are the those branches which do not contribute significantly to the predictive accuracy. Pruning involves cutting off the parts of the tree that are not necessarily or may be causing overfitting. The two main types of data pruning are pre-pruning, that is early stopping. So the idea is basically to stop the tree building process before it becomes too complex. So the methods are maximum depth limit, limit the maximum depth of the tree. Once certain depth is reached, stop growing the tree. As simple as that. Minimum sample per leaf. Stop splitting the node if the number of samples in a leaf node falls below a certain threshold. Next, minimum information gain. So, stopping the splitting if information gain is below specified value. Now, next, it is a first type of pre-pruning, early stopping. Then next type of pruning is post-pruning method. So post-pruning method, also known as reduced error pruning. So the idea behind the post-pruning method is to build a full tree, then prune it by removing the nodes that do not provide significant additional predictive power. So the procedure are as follow. Transfers the tree bottom up. For each node, consider removing its subtree and replacing it with the leaf node, representing the majority of class in a subtree. Evaluate the performance of the prune tree on a validation set, and if the prune tree performs better, keep pruning. Otherwise, revert to the original tree. That's it. So that's it for today, guys. Hope you are doing well. If you have any doubts, obviously you can ask in the comment section. I would be very happy to solve your doubts. Thank you so much and stay tuned for next video in our series of data science. Thank you so much. Thanks for watching.